Good morning. Today we are going to discuss about self-compacting concrete. Commonly known as SCC. By the term, what we understand from the self-compacting concrete is there is no need of compaction while we are placing this concrete in a structure. Is it possible to attain a structure without compaction? Yes, it has been done in the past while placing concrete under water, but while doing so, they were able to achieve a concrete without vibration, but proper quality has not been maintained throughout. So, the researchers started working in that aspect, and in the early 1990s, Japan was the first to produce a concrete which compact itself without any vibration, and that is a concrete called self-compacting concrete, SCC. And in the year 2000, Japan started using SCC in various structures and also achieved, and in the year 2000, Japan started using this SCC in various structural works, and also they achieved, and in the year 2000, Japan started using this SCC in many of the prefabricated works, and it has become popular during that time. And from then, many European countries started recognizing the use of this SCC, and in the year 1989, they founded EFNARC, European Federation of Natural Trade Association, which represents the producers and applicators of specialist building products. This EFNARC formed the various guidelines for the usage of this SCC, self-compacting concrete. And this self-compacting concrete has been described as the most revolutionary development in the concrete era. How it originally originated was mainly to this SCC was mainly originated to offset the manpower which was in shortage. This SCC was originally originated to offset the growing shortage of skilled manpower, and it also proved to be beneficiary in many aspects. It resulted in faster construction, reduced noise level, better surface finish, easier placing, greater freedom in design, thinner sections, safer working environment. Material for SCC. What are the materials required to produce this self-compacting concrete? As usual, cement, aggregates, mixing water and chemical admixtures. This cement can be of OPC 43 or 53 grade. This aggregates, since it is a self-compacting concrete, this aggregates played a major role, that is, the maximum size of aggregate was limited to 20 mm and the aggregates of size from 10 mm to 12 mm was the most desirable one for making this SCC. That is why they are limiting the aggregate size to 10 to 12 mm is whenever a concreting is to be done in congested reinforcement, there this 10 to 12 mm aggregate can be easily placed in between the congested reinforcement without any vibration. For that reason, they are restricting the size to 10 to 12 mm, since in this SCC will not be giving any vibration to the structure formwork. This is with respect to coarse aggregate, and with respect to fine aggregate, it can be a natural or manufactured. It can be a natural or manufactured sand. And if any particles less than 0.125 mm, that is 125 micron, is being used, then they are termed as fines, and this fines will contribute to powder content. Mixing water, water quality is to be maintained throughout the batch. Water quality is the same which has been used in the ordinary reinforced or pre-stressed concrete. The same quality of water should be maintained for SCC also. Chemical admixtures. Since no vibration is to be given to the concrete, that is, the concrete should flow by itself and should occupy the formwork. So, this chemical admixtures played a very important role in producing this SCC. Superplasticizers are essential component to produce a workable SCC. And apart from the superplasticizers, other different types of chemical admixtures used are viscosity modifying agents, air entraining agents, etc. With the help of these, we'll be able to achieve a workable SCC. With these chemical admixtures, we'll be able to achieve a high degree of workability of SCC. And next is mineral admixtures. In mineral admixtures, we can use fly ash, GGBFS, silica fume, stone powder and fibers. So, these are the material requirements of SCC. Now, we will see how the composition for an ordinary Portland cement and an SCC gets varied. This is for a traditional concrete. This is admixtures. Admixtures in traditional concrete, just traces, whereas for SCC it is in the order of 0.01 percentage. This is fines percentage. In traditional concrete it is 12 and in SCC it is 18 percentage. Then sand, this is a percentage variation in traditional and SCC. This is coarse aggregate and this is water. This shows the percentage variation for a traditional mix and a self-compacting concrete. Next we will see the ways in which this SCC can be made. In three different ways we can make this SCC. One is powder type, second is viscosity modifying agent type, and third one is the combined type. In this powder type, we will make the SCC by increasing the powder content, that is the fine content. The particle size less than 125 micron will be more in this powder type SCC. In this VMA type, we will make SCC by using the viscosity modifying agent admixture, and in the combined type we will be using both the powder and the viscosity modifying admixture. Next we will discuss about the requirements for self-compacting concrete. The main characteristics of the SCC are the properties in the fresh state. In the fresh state, how it's behaving, since there is no need for compaction, then at fresh state it should be a readily flowable concrete. So what are the requirements for the fresh state properties we will be discussing now. A concrete mix is said to be a self-compacting one only if it satisfies the following properties. A concrete mix is said to be an SEC only if it is satisfy the following characteristics. First one is filling ability. Second, passing ability. And third is segregation resistance. And several tests has been framed to characterize the properties of SEC under the guidelines of FNARC. And I will show the list of tests which are being used to determine these properties of SEC. First is slump flow by Abrams cone. This test will determine the filling ability property of SEC. So let me give the heading as property test method. Second is T50 centimeter slump flow. Again, this is used to determine the filling ability property. J-ring passing ability. V-funnel filling ability. V-funnel at T5 minutes. Segregation resistance. L-box passing ability. U-box passing ability. Fill box passing ability. GTM screen stability test. Segregation resistance. Aurimet filling ability. And these are the different test methods which are being used to determine the property of SEC at its fresh state. Next we will discuss about its production and placing. Aggregates. The aggregates which are to be used in SEC should come from the same source, and it should and there should not be much variation in its size, shape and proportion. Not much variation in size, shape and moisture content. Next is mixing. Any suitable mixer can be used. Generally, the mixing time can be prolonged when compared to that of a conventional mix. And we have to ensure that each batch is giving the same quality, and each batch and we have to ensure that each batch is giving the same type of quality of fresh concrete. Prolonged mixing period. Next, placing. Formwork should be in good condition to prevent leakage. Formwork should be in good condition. The limit of vertical free fall is 5 meter. And in order to prevent segregation, the limit of vertical free fall is 5 meter, and the limit of permissible distance of horizontal flow from point of discharge is 100 meters. And the limit of permissible distance for a horizontal flow from the discharge point is about 10 meters. Curing. Since this SEC contains very fine powder, it tends to shrink faster when compared to that of the ordinary concrete. So, polythene sheets should be used effectively to prevent the shrinkage, cracks while curing SEC. And also the initial curing should be commenced as quick as possible after concreting is completed to prevent the shrinkage, cracks. Next, we will be discussing about lightweight concrete. Why this lightweight concrete emerged is because mainly due to the disadvantage of the conventional concrete, since it is having a higher density in the order of 2250 to 2600 kilogram per meter cube. This heavy weight in some extent makes the concrete, normal concrete, as disadvantage. And attempts have been made to reduce the weight of the concrete, and in that attempt the concrete which emerged is the lightweight concrete, in which the density varies from 300 to 1800 kilogram per meter cube. There are so many advantages of having lightweight concrete. because of having lightweight concrete, the dead load of the structure is reduced, and it also helps in reducing the handling costs. And when the foundation below, if suppose it is to be laid on a weak soil, then this lightweight concrete will be a great advantage. And in framed structures, the beams and the columns are the load transfers, and in framed structures, if this lightweight concrete is being used, then a small load, and in frame structures, if this lightweight concrete is being used, then there it results in the less load transferred to the soil beneath the foundation. And there is only one method for producing this lightweight concrete, that is by inclusion of air, but practically it is being done in 3 different ways. One is using lightweight aggregate, another is by introducing gas or air bubbles in the mortar, and another is by omitting sand fraction, also called as no fines concrete. We will see how this lightweight concrete is being produced in these 3 ways: lightweight aggregate. And this lightweight aggregate, by the term we can understand that the aggregate which is going to be used in concrete is of lightweight, and it can be 2 types. One is natural lightweight and another one is artificial lightweight. Examples: pumice, diatomite, volcanic cinders, rice husk, sawdust. And in artificial lightweight, artificial cinders, coke breeze, foamed slag, expanded perlite, and these are the types of natural lightweight aggregate, and this is of artificial lightweight aggregate. By making use of these aggregates in concrete, we will be able to achieve lightweight concrete, and that lightweight concrete may have a strength varying from 0.3 Newton per mm square to 40 Newton per mm square. Next is aerated concrete. Here in this aerated concrete, they will be introducing air or gas into a slurry of Portland cement composition to form cellular structure. So, by introducing a mixture of gas or air into the freshly mixed mortar, we will be able, finally when it hardens, we will be able to achieve a cellular structure which will be of lightweight. And in third type, no fines concrete, we will be omitting the fine aggregate content and only single sized coarse aggregate will be used, so that only single size coarse aggregate will be used. So by doing so, we will be able to get large voids in the system, which automatically reduces the weight of the concrete, and in this way we will be able to achieve lightweight concrete.